Okay, well, thank you everyone for attending. And my name's Kylie Payne. I'm the Landcare Networker for the WA Landcare Network. And beside me, I have Jacqueline Lan from the WA Landcare Network, who's our Executive Officer. And so, yeah, just want to welcome you all to this, our Landcare Checks In, which will probably be our last one for the year. And our Landcare Checks Ins have been supported through our state NRM grant, so we're very grateful to them for that. And we've had a lot of people join throughout the year. We've had a lot of them. So we've got a great topic to finish off, which is helping farmers to understand soil health. Firstly, I'd like to acknowledge the First Nations people as the traditional custodians of the lands on which we gather. And we recognise their knowledge, their management and their connection to the land and waters of our beautiful state. And we respect all elders and ancestors and any First Nations people here today. And I want to acknowledge that I'm zooming from the Wajak people. I'm zooming from the Noongar Budja, where I'm located in Perth today. And you might want to note in the chat which First Nations country or area you are zooming from today. So welcome everyone. And just some ground rules. If I just said to the people that joined earlier, if you want to rename yourself, that's helpful. If you haven't got your full name coming up on your Zoom, and you might also want to, particularly your first name's helpful, and also you might want to put where you're from as well. That's helpful. It's helpful for the speakers as well. You just, you click on the participants, then on rename, and you can more. And during the session, if you want to ask a question, you can use the reactions panel along the bottom and put your hand up, or otherwise you can put your question in the chat. So I hope that all makes sense to everyone. And yeah, we'd like to have this as quite an interactive session, so feel free to ask any questions or as we go along. So to start with, I want to welcome our guest speakers today, and who are going to interact with us and tell us about some exciting new things. And we're very honoured to have Emerita Professor Lynette Abbott, who's a Senior Honorary Research Fellow from UWA and a very worthy winner of the 2021 General Jeffery Soil Health Award. And we've also got Cassie Howell, who's a UWA Honours student working with Professor Lynette Abbott, and she's going to talk about some of her findings on her honours project. But first, I'll hand over to Professor Lynette Abbott and to tell us, well, she'll tell us what she's going to tell us about, but mostly about her recently released Soil Health App. And just before she starts, if everyone can put themselves on mute, including me, that will be good just while the speakers are speaking. Okay, thank you very much, Lynette, and we'll hand over to you.
Thanks, Kylie, and hello, everybody. I can see quite a number of people with their names on the screen. I can't see all your faces, but I'm just going to start the ball rolling with an overview of the Soil Health App. Now, I'm going to ask you a question first. Has anyone downloaded the Soil Health App onto their phone? No? Well, that's good, because maybe I'll do that. But I'll just let you know, don't do it while you're driving around or not at home with the Wi-Fi, because there's quite a lot of downloading, and it's better that, and it's probably also faster if you do it at home. So that's sort of my introduction to it. So I'm just going to flick to share a screen, and I've got a little PowerPoint, and when I get it to work, and so can you see that? Okay, I'm assuming you can. Someone will scream at me if you can't see it. So that's interesting. It's cut off the top bit, but never mind. So this was a I've been working in this area of soil health for a long time, even before it wasn't sort of acceptable to use the term soil health. And the idea of doing the Soil Health app was from Cheryl Rimmer, who's been working with us. And she was very techie, and she worked out how to make an app and how to make it so that it fitted on both the platforms. And she got me to bundle a whole lot of information onto the app. So the app's free. It's called Soil Health, and it's available in Android and iPhone. And you click on the little icon. There's a couple of things that come up with Soil Health when you go in, but it's this icon that you want to, this little thing that you want. And then it was funded by, we got a small grant, very small grant, by the way, funded by the National Landcare program in the Smart Farms program. And so it's free, it's easily downloadable, and it works internationally. It's not just for Australia. So on the app, there are animations, podcasts, and a little soil health ebook. It's quite a big one, actually. So this is the ebook, and I've just got the title, the table of contents here. So it covers these headings, and it's a summary of a book I've written, really, which will hopefully will come out early next year. So the contents of it is basically an introduction to biological fertility, and these headings are all covered in it. And for each of the, I'll come to the acknowledgements in a minute, but for each of the pages, there's a brief statement and then a picture. And that's really what it is. It's not no references, it's just a little statement. And there are 90 pages in this ebook, and it's just like flicking through with little statements. Now, all the follow-up of the information in the ebook will come along in the book, which I'm actually going to publish. But it's just an idea of putting a lot of information in front of people in a very simple format. And there'll be other information that backs up. You could write a book about each page. But just to acknowledge again that Cheryl really was the stimulus for getting me to put this together. And she worked out how to create this app and to make it really quite simple so that it could be used anywhere. But the issue I mentioned is that we just need to make sure that you don't download it while you're driving your car and you're using up all your data. And in addition to the government funding, Southwest Catchments Council helped us promote it as we went. So as we developed through and we were getting information, they helped to disseminate that information, and we're really grateful for that. So the animations are all about 2 to 3 minutes. They're very short, and they were made to just take a piece of information and look at it in depth. So each one probably needs to be watched several times to get the full value of the information out of them. They were done professionally outside of this grant. It wasn't part of the funding for the grant, but Lush Digital prepared they were just amazing in the way they put these apps, these animations together. And based on information that I had from the book, they then prepared about 200 words, which I then just fiddled with it slightly. But they picked interesting little bits bits they thought were interesting to give a section of the whole topic of soil health. And it covers the wide range of issues. So the animations, they're not labelled. You need to actually watch them to see what they're about. And that's done on purpose because you can't explain it all in detail in just a couple of words. But that's the animations. And I think you'll find that they have been done really well. And then there's a series of podcasts which are probably not as high quality because of me rabbiting on about soil health issues. And these are the topics that are there. We've got another 6 that I haven't loaded up, but the aim now, and Cheryl made the app so that it had this feature, the podcasts are actually adaptable. So we can change, we can add, we can remove them, we can put new ones in. And what I suggest to you is if you've got any topics that you would like addressed in the podcast that we can add, or if you've got farmers you could do an interview with, or we can have a bit of, we've got lots of flexibility. We can add podcasts that are relevant to people in this system. So the app is flexible in that the podcast can come and go and be up to date with interesting things to do with what you're interested in, and we'll add other topics ourselves, but I think it's important that you can actually interact with us on that. And I just get a bit of background on why am I doing this, because I grew up in soil science with people talking about fertility, and really it didn't make sense to me what fertility was, because it was usually focused on this bit, the physical, chemical fertility, with a bit of acknowledgement to this. But the biological fertility, which we've been focusing on now for many, many years, interacts with both, and that you just get this sweet spot in the middle where things mesh together. And that's what all our research is really focused on, getting that bit right, so you bring a holistic approach to the whole thing. And then it's led into, well, what can you measure? You can measure chemical, physical, and biological characteristics, and you can measure chemical, physical, and biological processes. But how then do you relate that to the whole soil health story, which is then what I've spent most of my career doing. So I'll just stop there, and I'll stop the share and come back to you to see if you've got any comments or questions at this point. And then the next part of it, the next part of it is more about what we're doing at UWA Farm and sort of investigating this whole thing at a landscape level and a Landcare focus. So are there any questions?
Mine's more of a comment, Lynn. I just wanted to congratulate you, and I was working with SWIC as we were rolling the little animations out. They were fantastic. People really engaged with them, and I sort of look forward to the follow-up one. I learned a lot about soil through those. So I think it's a really engaging thing that you've created there. Well done. And I see Ella's ready to ask a question.
Hi, Ella.
Unmute, there we go. Yeah, just a question about those animations, actually. Are they available outside the app? Like, are they on YouTube or somewhere we can get them and share on our social media platforms with our farmers or something?
They are, because Southwest Catchments Council tweeted them out, as you know, from time to time. And so there is a site that they set up. I just have to track where that is, because I haven't done a lot of tweeting out, because this is part of a bigger package. So the aim is that we're rejigging the whole of our website, which is we've demolished most of it and we're putting it back together. And Cheryl has done a lot of that, and we'll release that early in the year. So the package is the app, the website, and then the book, and they all come together. So once we get the whole lot, we'll do more. But getting back to your comment about the animate, they do exist somewhere. I could just check with Peter Clifton. Okay. Maybe you already know, Jack, where they are.
I'll say, I know Peter. I can just look him an email.
Yeah, they're sitting. He's got them somewhere. I mean, we've got them too, but I think Peter set them up in some place that they're very accessible, and they're free. Yeah. They can go wherever you like. It doesn't matter.
I'll jump in and introduce Dan Lepardo, who's recently joined SWIC as the Ralph. So he's in Pete's role now, and Pete's the Sustainable Ag Program Manager, replacing Mike Christensen, who's retired. So Dan might be a good contact too. Dan, if you want to pop your email address or phone number in the chat, that'd be great. Thank you.
Dan, I now know what your face looks like, so I've been emailing you.
That's good.
Okay. Anything else? Anyway, so hopefully you'll be able to download it and fiddle with it. And you can also feedback if it's a bit clunky perhaps for you. But we certainly have opportunities to fiddle with the podcasts and put ones that are relevant to you. But we don't have a lot of opportunity to change the rest of it in the format, because it was a very small grant, and also it's fixed. So, but if there's a major disaster, problem, we can fix that. Okay. So shall I move on to Jack? Okay, I can move on. Okay.
Yep.
So I've got to remember what to do here. So I'll just move on to the rest of what I was going to do. See if I can work it out. Oh, I just put this in. over the years, we've done a lot of things. One of them was working with Wheatbelt NRM, and we ran workshops. And this is a farm little monitoring handbook that we prepared, which is on the website for Wheatbelt NRM. And in this, we were trying to put up some information, not scientific as such, but more of a bunch of information that farmers could do themselves. And it focused on looking at soil animals that they can extract and get a feel for how the soil animal community changes over time. Very simple, can be done at home. And we also, a lot of people are interested in mycorrhizal fungi, which is my expertise, but it is possible to take samples of roots and stain them in your laundry or your kitchen with fairly benign chemicals. Normally we use quite things that are a bit dangerous for common use, but you can stain roots and have a look at mycorrhizas. It's not so straightforward, but it's explained here in this little booklet on the NRM, Wheatbelt NRM website, but I'm always available to help people if they want to do it. And I think that you can send your samples off to all sorts of people, get them analysed, but I think my focus has been understanding what is going on. And so understanding simple soil tests is part of what I'm interested in. So if I just move, you can't see, I don't know if you can see the top of it, but my screen doesn't show the top of this. But this is UWA Farm. And over the years, there's been a lot of work done to try. This farm was bought. It had been almost cleared, nothing there, just some little hilltops that were left. And over the year, there have been a number of projects trying to put the vegetation back in the natural vegetation. So just skimming through, there's been long-term trials through the Future Farm CRC, putting perennials back into pastures, feeding sheep with native plants to help reduce methane. I mean, that's a very common, and everybody's talking about that now, but this work was done with CSIRO and UWA, like a long time ago. And the remaining shrubs are currently part of the pasture. And so the benefits are in what they can eat, but also in just restoring the land using a mixture of agricultural and native plants. And there's a big long-term trial where primarily eucalypts have been planted. And Murdoch is now looking at carbon sequestration in that site. There's another site, which if you see here, it was a pretty poorly managed pasture, and it had some salty areas. And this is what it looked like the other day when I was on the farm. And we restored that using perennial pasture species and shrubs. So I'm just looking at the time. I don't want to take too much time. And then there have been a lot of projects over the years with school children going to the farm, planting trees. And if you look at a landscape level, you can really see the difference this is made, primarily targeting areas that had potential to be salty or a little bit of erosion. There's not a lot of erosion on the farm, but the school children have contributed enormously over the last 10 years to the restoration on the site. And we've had lots of trials looking at manure. This is more impact of management on agricultural land. And Sasha Jenkins, who's standing here talking to people, has been leading a lot of that work. And then most recently, we've had a project in the carbon farming UWA government project. And this is the site. I'll just show you where this is the farm. You can see it's just been cleared enormously, this site. So this is a little creek that runs through. This is the original farmhouse. But this site just needs a lot more planting. And our field trial is sitting here. And it's a mixture of annual pasture plus perennial pasture and soil amendments to see over a 7-year period how or whether we can increase the soil carbon over that time. So this is a part of the long-term restoration, and this is some of the perennials we've just put in. And then there's another site which is Cassie has been involved in, and this is a site at Brookton. And originally it looked like this, and the people who own it are the Fisher Wattses, And they took this paddock and they turned it into this. And they did something that was quite unusual. They added mixtures of organic material as like, well, they call them barriers, so reactive barriers, and they fill them with biochar and a whole lot of other things. And they're like filters between salty water coming through the system and then the growth of the trees. And so this is what they did. They made these little holes next to the trees and they filled them with goodies. So they're filled with lots of organic material, which is quite an unusual thing to do. And over time, they really established these trees, which are a lot of natives. So they have honey and they have a lot of seed production on this site. But so we took that idea into a Landcare project, and this was the site on UWA farm, which we chose to implement this kind of practice that the Wattses have been doing. And it really was in this, if we hadn't intervened at this site, it would have become a lot more degraded. So we'd already planted trees on the site with Greening Australia, and then we superimposed this grant for the project from the Australian government, the National Landcare Program, over the top of it. And we introduced these permeable biomass trenches and walls and holes. And we put it in like this, where we put holes next to the trees. And you can see the trees have been growing over the years. We filled them up with a whole lot of organic matter. And then the idea that we had was that the roots of the trees would grow into these holes and proliferate. And they'd be like little compost heaps for the trees. Now that is, in a Landcare sense, that is not a major benefit likely, but if they were trees with like financial benefit, which you might be for honey production or whatever, then it's something that can be used, or it can be applied in orchards or in re-veg in a mine site, for example. So that's a project that we've now finished. And the basic thing was, in these holes, roots would proliferate, and instead of putting soil amendments across the whole site, we've actually been able to just put them in these little holes. So I will just go back now to Cassie and ask her to share her screen, because she was working on a site just near here, which was a lot more degraded, and she was trying to sort out what the problem was. So I'll stop sharing and Cassie can come in.
Okay, I'm assuming that we can see that. So hi everyone, my name is Cassie and I did my honours project with Lynn at the farm across 2020 and 2021. And so just to start off, sort of an overarching concept, looking at what we were doing at the farm, is my sort of focus is restoring native vegetation to highly degraded areas, and sort of in a mixed sense on agricultural land, but not necessarily in like a large scale cropping environment. And so in this diagram, it just demonstrates what we're looking at is both degradation and restoration can sort of be viewed as these very self-perpetuating cycles. On the degradation side, when we get salinity or erosion or any of those kinds of things, they lead to further loss that further leads to more degradation. So if you lose vegetation, as we know, especially throughout the wheat belt and a lot of environments in Western Australia, we get salinisation. When we get salinisation, we get further loss of vegetation. And so what we're sort of looking at trying to do as part of this project is, what can you do to flip that? So if you can start getting more vegetation into the landscape, then we start to stabilise the soil, we start to get rid of that salinity, and we get more vegetation. And so, as Lynn has touched on, we were looking at using different organic amendments and putting them into the landscape in different sort of techniques and seeing whether that could help support this sort of restoration process. So just to look at this specific site, so we had this area of revegetation. It's a quite degraded creek bed, And so we refer to it as a saline seep. So it's this area on the farm that is incredibly saline, as you can see from the soil summary. It also had a very high alkalinity, which we were somewhat surprised about, and very low nutrients. So pretty much the least ideal environment for anything to be trying to grow. And we just got a bit of a zoomed in. So we had this sort of hard pan situation. It's very salty, it's very solid. And so not much is growing in there. And in this revegetation area, as you saw from some of the pictures that Lynn showed, the revegetation was successful in certain patches, but in other patches such as these, there was a pretty much 0% survival rate about 5 years after the initial planting. So we knew that in order to plant things and get them to survive in here, we had to do something else, and that's where the organic amendments come in. So due to some COVID complications, and just to make sure that I could finish my honours project, we decided to do a glasshouse experiment. So we took soil from this area. So we took the very degraded, very saline soil and put it into a pot experiment and mixed in different rates of biochar and compost together and alone. And we planted in saltbush to see what would happen. And just to touch on the different amendments, there's a huge range of organic amendments. And one of the interesting things is that you can say something is biochar or something is compost, and they have generally similar characteristics, but it's important to remember that they can be created in very different ways and have a lot of variation. And so it can be quite specific to the type that you're using. So we can make generalizations, but it's also can vary a lot depending on the type of biochar or the type of compost. Compost, we know pretty well the positive benefits that it can have on plants because of the nutrients and the organic matter that it provides. But there was some literature to suggest that it could help with salinity and also with biochar. It's quite, it's a bit of a buzzword, a buzz product at the moment across a lot of different uses. But one proposed use is that because it's it's highly porous and can absorb a lot of different things, that it might have the ability to absorb and ameliorate salinity within the landscape. And so that was one of the reasons we wanted to see what impact it would have on this particular site. So just a quick summary of the results. Compost, quite expectedly, had a really positive impact on root and shoot biomass across the board on the saltbush that we planted. Somewhat unexpectedly, the biochar had no impact, and we weren't really seeing any interactive effects. However, when we assess the impact on some of our soil indicators and different soil chemical characteristics, we see that both compost and biochar could have quite a positive effect on some of the limitations that we had in the landscape. Very interestingly, electrical conductivity as representative of our saline conditions, there was pretty much no impact, but there was quite a significant impact on the pH, which suggests that maybe the alkalinity was more of a limiting factor than the salinity in this particular case. And so going on from this, we would want to investigate how this actually converts into the field, because the pot experiment's great for getting some understanding, but if we want to apply this as a technique, especially that farmers and land managers can use, we need a better understanding of how these amendments can be used in the field. And so part of this, we do start to get an indication from the trench experiment that was set up earlier. And so as you can see in here, this middle section, which is filled with biochar, straw hay, all sorts of compost. In this middle section, it's about 30 to 40 centimeters wide, I think, and 20 to 30 centimeters at least deep. So quite a good amount of material in there. And then on either side of these trenches, we've got these seedlings planted. I've highlighted them in pink because they're quite small. This was the initial planting at a field day we did with Wheatbelt NRM in September of 2020. And so here's just a further demonstration of running down the slope, you can't exactly see it, but running down the slope, we have a trench with this organic matter rich material, and then a planting, and then a trench, and then a planting. And so what we were hoping might happen is, as this very saline water is moving down the profile of the slope, that it's getting filtered through these trenches. And at the same time that the plants planted between these trenches are also growing, and eventually their roots are able to enter into these trenches and take advantage of the organic matter. So a similar concept to what was used in the like holes, but just using it in a different sort of format across the landscape. So this was, in September of 2020, we go forward about a year and a half, and this is what that site starts to look like now. And so obviously the seedlings have grown because I don't have to highlight them on the screen. And I think it's good to note that, so this has had 2 summer seasons, including the most recent summer, which, as we all know, was ridiculously hot for a very long time. So not at all ideal conditions for seedlings to establish when they're already in potentially saline, alkaline, relatively low rainfall soil. So we can see that there was a genuine positive effect that was had. And in an area where the revegetation has previously completely failed, we've now got both very salt tolerant species in our salt bush, but we've also had pretty good survival of our eucalypt. The growth is pretty variable, and this, as you can see in this middle strip, so it's so successful that you might think that wasn't part of this planting, but all of this in this middle bit, all of this were all planted together. So you can see that it had a very variable effect. In this upper slope area, survival was still quite minimal. We can't fully assess whether that's due to it being at the upper slope, so it's had the least filtering impact from the trenches, or any other impacts, but we can see that as it goes down, we've had a lot of success in here, and even still a reasonable amount of success in our plant survival here. So very positive initial results, and it's good to see that the eucalypt survived as well, because part of the concept and part of my hope eventually is that we kind of know that we can restore most saline areas just with saltbush, but the aim would be to restore with a biodiverse range of non-salt tolerant plants, and hopefully using techniques like this and our different organic amendments, we can start to support a wide variety of restoration. Yes, thank you all for listening.
Excellent. That was absolutely fascinating, Cassie. If you just, stop sharing screen and just open to the floor for some comments and how we might, as a layperson, the complexity of a couple of things that really came up for me, that, you know, one of the constraints in the situation for the soil was the alkalinity, perhaps more than salinity. And then, you know, the outcomes of that trenching experiment, and we're all working in that behaviour change space for farmers. And I'm wondering if anyone's got thoughts about how do we communicate this for best effect? Ella?
Sorry, took me a moment to unmute there. No, I was just looking at those pictures of the trenching. It was really interesting how you were talking, Cassie, about the basically using the trenches to intercept the saline groundwater as it's coming down the hill. I noticed in the second lot of photos, the after photos, that as expected, the organic matter in the trenches had sort of decomposed and gone away. Do you think that that needs to be refilled over time to continue with that filtering effect? Or do you think that it's really there as an initial stage to get the seedlings established, and once they're big enough, they don't need it anymore? And then if so, what does one do with the ankle breaking trenches in the vegetation then? So yeah, my question is sort of what you do with it post that initial stage.
Very good question. definitely the second part, the ankle breaking, not quite something that I have thought about. So definitely something to think about in future. I think my view, and Lynn sort of touched on this earlier, it depends on the purpose of what you're trying to get out. So if you're really trying to get extraordinary plant growth, and yeah, if it was more of potentially like a native bush food planting or in an orchard setting, you might want to be replenishing that organic amendment to get the added growth benefits. But my view is definitely that it would appear that it's really about getting over this initial establishment barrier. Given that a lot of the other revegetation through a very similar area has survived, it's just getting over that initial barrier of putting seedlings into a really toxic, really environment and getting them to survive long enough that they can start to sort of look after themselves. So it would definitely be the hope that it's not a completely ongoing process of restoring that, but depending on the area and the plants that you're putting in, I imagine that it could be a few years of potentially adding more in if the salinity and the alkalinity and the other limitations are such that you need to help the plants to survive more than one growing season. Obviously, we didn't add any more to ours, and I think Lynn's been there more recently than I, but the plants are still alive. But it could vary depending on what limitations you're trying to fix and what purpose you're trying to get out of the plants that you're putting in.
I just might add, when we had this site originally, the patch that Cassie's been working on, we thought it was rock. And we thought that was why, no, but it just was just hard, compacted, eroded, to do with this seep that was coming. So I think I agree with Cassie about breaking that up, getting something established, and it wouldn't be profitable to be spending a lot of input into a site like that, but getting it to halt the continued erosion in that area, that was an important thing to get vegetation back. And it was a patch, it wasn't like the whole hillside or anything.
Well, and actually, I might just follow that up with one interesting thing that I like talking about because I didn't get to put it in my thesis, was that in my glasshouse experiment, I started having what I thought was a weed showing up in a lot of my pots with the high amendments, but it was actually a species of saltbush that was definitely not present in the glasshouse, but was obvious, and I've investigated it. It would be native in that area, but it wasn't present in, like, growing wise in the area that we'd taken the soil from. But once we amended it, the conditions became favorable to the germination and growth of this species. So it was just initial findings, but it suggests that if we can amend it to a certain point, the landscape itself and the plants themselves can actually start to overcome that barrier, and we could get the seed bank that's already existing to start restoring itself without us necessarily having to continually even replant different species. Which I just thought was super cool, but I wasn't allowed to talk about it.
Well, we're glad you did, Cassie. That's fascinating. Isn't there a story about a bog in England where a similar thing has happened? They've done some remediation around the bog and taking some of the toxicity out, and they haven't had to revegetate it. All of the pieces that used to live there before the chemicals came are starting to do it for themselves. And isn't that a wonderful thing? Just amazing. We just had someone late join us. Brad is here. And any thoughts, questions, sharing anyone wants to do while you have access to these amazing researchers here?
Well, maybe, Brad, if you can hear me, I talked about the Soil Health app. So if you go searching on the internet or on your whatever you do for your phone, you can have a look at it. I think you'll follow what we're getting at with that.
Okay, so Lynn, you had a few more slides there. You thought that if we had a bit of time, you might like to squeeze a couple in.
I just had one, just a minute. There was just the last one, which is sort of a bit of a summary thing. I don't know where I'm up to now. Where am I up to? Yeah, I just had this one. And it just comes back to where I started with the Soil Health app, because you know, the whole of my career, I've been trying to understand microbial processes in relation to soil function. And so I just bring that story back to what I'm trying to do with the app, and put information for people to get a bit more of a handle on soil biological processes. And in all of this thinking, we're interested in how soil carbon functions, because obviously everybody's interested in soil carbon now, but the whole point is that most organisms in soil depend on the soil carbon in that general sense. There are some organisms that don't get their carbon directly from organic matter. They can use carbon dioxide, and it's important in the system. But so this being interested in landscape restoration gives that focus on, well, how does soil biology work? Because as I said earlier, the soil fertility historically had a focus on chemistry and nutrients. So you measure, have you got enough nutrients, then you can grow a crop, or you can grow past whatever. So that focus on how biological fertility links to chemical and physical fertility is really what our thinking and our research has been all about. And then, just in summary, just these last couple, that sort of small scale picture underpins everything that we do, whether it's the landscape scale of land restoration and the studies that I explained to you, and also putting the vegetation back onto Ridgefield, because you could see from the photos, you know, it had been just completely, everything that could be removed was removed except for some hilltops. But UWA Farm Committee, the group that runs this farm, it's a commercial farm. It's not a toy farm. It's about, it has to make a profit. The university treats it like a proper farm and commercially. But the idea of how we then, in that context, we bring this focus on biological fertility into it. And that includes restoration of habitat and natural vegetation. And the aim would be to build that up to 20 to 30% if that was possible. And obviously we're a long way off that. But that's the thinking. And how can a farm do that in a commercial sense? It's not easy, you know, it's a long-term thinking. And obviously a lot of people are working hard on that across Australia. So we want to do our little bit, but we're nowhere in the realm of what a lot of people have achieved. But the idea of the work with the Brookton study was to have an impact on this smaller scale of restoring damaged patches. And that's why what Cassie did really fitted into the big picture. So if you can stop patches of severe erosion, and that farm is not completely saline, it doesn't have a lot of salinity on it, but little patch that can lead to a bigger problem, we nail it, fix it, and that's part of the overall plan. So that was just my finishing off touch. Hey.
Thank you very much, Lynette. I'm wondering, from the people who work directly with farmers, just as a bit of a quick conversation, what sort of response are we getting from farmers as we share more and more of the story about the aliveness or the complexity of soil, and how easy is that for farmers to engage with? Well, the app, I think the app will certainly help them with that, in terms of, you know, the local context of their soil. Jamie, anything you want to say there?
I don't work directly with a lot of farmers in all reality, and I'm not sure that in my observation, and others can comment, that there's actually been a coordinated extension program. There's a number of different organisations doing things, and we've just heard prior to this from what Soils West are doing. There's some, I guess, maybe some minor work at Deeper, maybe not at all. But yeah, there's probably others here that might work with more farmers than I do. Some people, my observation will be that some farmers just tune straight into it, and other farmers are just remain committed to, you know, the old chemical or chemistry, physics, soil physical structure is really important. So, and I don't know, look, it's hard to say whether it's how challenging it might be to change someone's view, but I think it needs some consistent, systematic work, and I think we need to coordinate maybe better at state level. Just listening to the work that Soils West doing earlier, I think, you know, these guys are heading in the right direction.
That's a really useful observation, Jamie. Thank you. And it's something that is that Wong can look at how we can help to advocate for that perspective. It's certainly not the first time we've heard that there isn't a coordinated extension program happening in the space. And, you know, maybe there's enough happening now about soils to really start to pull that together.
Yeah, one of the major issues, and I see this from where I sit in government, is that there's been a lot of interest in regenerative agriculture in the last, in WA at least, since our minister came on, who's since, well, she's retiring from the role. And so there's the smell of money, and it makes people very competitive, and everybody's trying to grab a hold of a bit of money to do something. And I don't know, I think that's detrimental in the long run. And it's very difficult to change from that. Government's always put out, you know, grant schemes where you've got to come up with the very cleverest application to get the money. So not sure how we deal with it, but in the first instance, getting a whole bunch of the relevant organisations in the room together, because I don't think government should lead necessarily or control. I really think that the really good work gets done at grassroots level, and we should find our best way to support that. And but at least some good communication across all the players, and potentially some coordination to help leverage more value from the resources that are available, because there's so many passionate people. It's, you know, that's not, to me, that's not really the issue at state level at the moment. There are broader issues.
That's fantastic. You've given us some rich material there to be able to follow up on through our various channels, and we certainly haven't had anybody yet saying, you know, that's not their experience. It seems to be there is a gap and an opportunity to look at this, and new emerging stuff does always create that sort of big appetite. We're seeing it in the carbon space over the years. We're going to see it in the biodiversity market. So it's just want to talk to the chat here. Debbie Holtham from Dwyer. Hi, Debbie, said, would Lynette be available for a webinar or a Zoom meeting with farmers to demonstrate the app, and that she could coordinate this?
Sure, I could do something. Yep.
There's Debbie. Hi, Debbie.
Hello, excellent. Oh, thanks for that. Because we work with a variety of catchment groups who are in touch with farmers. So that would be very easy to coordinate something if you could provide your knowledge.
Sure, yeah.
Okay, sounds good. Thank you.
What Kylie generally does after a Landcare checks in is circulates content and materials, and the talk will go up on the YouTube channel. People generally give, or the website, give permission to exchange information. So something will be coming out where you'll be in touch with Lynn. You can follow up through that. And I think that could be a terrific model, Lynn. We don't want to wear you out, but how would you feel about doing a series of these directly for farmers?
No, I'm I've had a long time. I've been giving workshops to farmers for decades, and it's interesting to hear what Jamie's saying, because you know, it's how you can raise awareness, you can raise awareness, and then you can raise knowledge, the whole linking right through to implementation of the change in practice if required. You know, this is not straightforward. I understand that better than anyone, I think. And so, but listening to farmers is, I mean, I'm not just saying here's the information, it's all about listening and feeding back into what we know and how relevant it is. And that's why I think working at UWA Farm has been really good, because it is a commercial farm, and it's not a demonstration site, or it is well, we've got demonstration sites there, but it is a farm where if I want to do something on the farm, I have to get permission, have to go through a committee, it has to be linked to the commercial committee of the farm. So the farm manager has a big input into what we do and what we don't do. It's set in the farm, it's set in an economic context, whatever we do. So we can't just use up all the land to fiddle with things. It has to be part of the overall farming system with the aim of improving and making money, making it commercially viable. So what we think about, although it might sound like it's fascinating to know all about the little ins and outs of the biological processes, but what I'm really interested in is why those biological processes are important in the long run in a sustainably managed farm, because, you know, we can override them easily with just making sure the nutrients are okay. And that's very financially viable, which is great. But is there another layer that we can include? And I know lots of people over the many years have helped me to explain this from the farmer perspective. So our little app is just a starting point, and there's a lot more information that'll come out early next year as well. But, you know, there is so much more interest now than there ever was. I started at a time I mentioned earlier that even if you said the word soil health, it wasn't considered to be scientific. It was, why would you use that word? It doesn't mean anything. So, you know, the world has changed, but I think we've got to a point where, in a commercial sense, there's a lot of interest in capitalising on this healthy soil space. And that's also something we need to keep an eye on, so that, you know, just more of good things doesn't necessarily mean it's better. And there are financial implications there, of course, too. So there's plenty to share in this space, and happy to talk to whoever is interested in the content of the app or the next phase of the whole story. So I appreciate your comments, Jamie. It was really, from your perspective, and you see a different world to me, it was really helpful. Thanks.
Terrific. I think we might have you back next year, Lynn, for the next phase, you know, so that people can keep up to date with what the next steps are. Any closing comments before I hand over to Kylie? Ella?
Sorry, you go, Ella.
Okay. No, I was just sort of, I think, jumping on a little bit from Jamie and Lynn, because I do work directly with farmers in my role. And yeah, there's certainly an increasing understanding and awareness and interest in soil health and looking at soil more holistically. But what I'm finding for so many farmers, there is this enormous chasm between interest and understanding and actually being able to implement. And so much of that is the constraints of time, labour, resources, money, of you're under the grind just running the farm the way it's always been done, and trying to then take these new ideas and have the time and space to do that while you've still got to keep pumping out the crop each year is a real gap. And one of the things looking at with obviously the cost of fertiliser going through the roof this year after with what's going on in Ukraine, I know a couple of local farmers looked at going for some more like compost-based and manure-based alternatives to fertiliser. And even with the price of the synthetic fertilisers as high as it is, those other ones were still even more expensive and more cost prohibitive. And so it's just these, you know, for me, it's really, really frustrating seeing farmers who are interested in soil health, who are doing the learning, but they just can't seem to get the time and headspace and reality to start actually doing at scale because of just the 1,001 things that a farmer are juggling anyway. And I see that as a real barrier still, and I don't actually know what the solution to that is.
Yeah. Jamie.
If I could throw a few comments in there, we did some evaluation work quite a few years ago now of the Sustainable Grazing on Ceylon on Land project. So that was a big deal, and it was led by Western Australia, and it was a really good project. And there was a bunch of different extension methodologies used in that project. Provision of information. All the farmers got Ed Barrett Leonard's recently edited Saltland Pastures book. There was some case studies done, some network forums held, but they all got 10 grand, and this is a 71 host farms, all got $10,000 to implement a saltland pasture system on their farm. Some of those farmers were experts at it already. They were just funding their next paddock. Well, good luck to them, because they were really useful in the network. They had a lot of knowledge. But the other thing they got was a lot of one-on-one tech support on farm. You know, guys like Justin Hardy, JP Collins, Arj, and these guys, you know, they knew the technical side of it really well. And when we evaluated it, we spoke to 25 farmers. We had to remind them all that they'd got Ed Barrett Leonard's book, and that was an information product. But they raved about the support they got on farm, about how to get a saltland pasture system going. This is more the newer fellas, obviously, or less experienced. And the $10,000, which addressed just exactly what you're talking about there, Ella. So, you know, I've been kind of pushing this in the background, but subsidies and grants for farmers, or even though there's been some in recent years, just seem to be a politically unsavory thing to do. And our bosses can't see past that, because there's so many other benefits that come from it. Like one of the farmers said to me, you know, their saltland pasture system failed completely, and they just went, it was really good because now I'm not scared to fail. I'm just going to keep doing things, just building that human capacity. So you made a really good point, Lynn, about the chasm between information and supporting action on farm. And Ella, you talked about those barriers which we need to overcome to support that. And I think that's the sort of stuff that our Landcare networks can kind of focus on, that end of it. You know, one-on-one tech support on farm for free at first, it's just immeasurable.
That's really useful too, Jamie. I mean, we've got RLP3 coming up, NLP3, whatever you like to call it. We're in some conversations at the national level about the sustainable ag component of that, and what some bits and pieces really do need to look like to hit the ground. Because as you said, the information's out there. Ella, and lots of people's frustration is, how do you support a farmer to do an adaptation trial? How do you actually assist them to change that behaviour with some sort of support? And there are some international investors, certainly lots of them coming into the space, where this kind of support, if the government doesn't want to be the sole player, or support, maybe there could be a dollar matching, or maybe we just look for that philanthropist who wants to really see regen take off and understands, look at the value you would get, you know, for a small amount for farmers. That's a small amount of money across a wide range of them to trial this and to see how they could develop the confidence. A bit like Lynn's saying, you don't have to tackle the whole farm at a time. You make a start, you see what works for you, you're networked up to all the other farmers, and you share and you do that peer extension and social learning about what's working. And then you've got something that, you know, rolls along. So there's some great thoughts there. I think that's terrific. Thank you very much.
Well, thanks for inviting us. It's been a joy to see you all. And some of you I know already. Some of your names I know. Nice to see you all. So thanks.
Yes, so thank you very much, Lynette and Cassie, for joining us today. So as I said at the beginning, this is our last Landcare Checks In for the year. And if you've got any suggestions for topics for next year, please email them through or get in contact with us. And just to let you know that our AGM for the WA Landcare Network is on Monday, the 5th of December, and it's going to be online, and we're also going to have some presentations. So you'll get some more information about that if you haven't already. So that'll be from 10 a.m. till 12 on Monday, the 5th of December. So thanks again, everyone, for attending. and we'll catch up with you next time.
Thank you. Bye.
Want to stay on, Kylie, please? Hey, they're all gone, I think.